The boy in this problem is standing on the top of a building, at the edge of the roof, when he throws a stone straight up at a speed of 22 meters per second. The stone will rise to its maximum height, fall back down, miss the edge of the building, and hit the street below. We're asked to find its speed just before it hits the street. We know that the initial height of the stone, y0, is 30 meters. That's the height of the building. The final height of the stone is 0. It's at the ground, and all during its flight, the acceleration in the vertical direction is minus g. It accelerates down at 9.80 meters per second squared. Part A asks us for the stone's speed just before it hits the street. We can find this using one of the kinematic equations because acceleration in the vertical direction is constant. The easiest one is the time-independent equation shown here. The square of the final velocity equals the square of the initial plus twice the acceleration times the displacement in y. The acceleration is minus g, and the displacement in y is final minus initial heights. The final height is 0, so we can rewrite this and substitute the values. When you take the square root and find the magnitude, it equals 32.7 meters per second. It's important to remember, though, that this equation only gives you the magnitude, not the direction of the velocity. The final velocity is down, so it's negative, minus 32.7 meters per second. The final speed is the magnitude of that, positive 32.7 meters per second. Part B asks for the time that elapses from when the stone is thrown until it hits the street. And for that, we can use the time-dependent velocity equation shown here. Solve it for the time. It equals the final minus the initial velocities divided by the acceleration. And now remember that the final velocity is negative. Subtract the initial velocity and divide by the acceleration, minus 9.80 meters per second squared, to find the time is 5.58 seconds.